Okay, so the Richter scale is a numerical scale that expresses the magnitude of an earthquake, and the scale is based on logarithms. The Richter scale is a logarithm scale, so that's how the logarithms tie into it, because the scale is based off of all of the logarithms, and it's used to calculate the magnitude of earthquakes. Okay, so this is the Richter scale formula, and the formula is over here. I just underline it in purple. And it's m, which is magnitude, equals a logarithm times 10, so I'm just going to put like a little dot in there so you know, multiplied by 10, because if you look over here at the scale of how the Richter scale is used, level 1 is unknown yet because we don't know. It's just 0 as of right now, but it'd be like 10 times level 1, so this would be 10. Or it wouldn't be 0, it'd be 1, so it's 1. And then, so it's just going to keep multiplying by 10, so you'll go 10 times 10, then that's 100 times 10 equals 1,000 times 10 equals 10,000 times 10 equals 100,000 times 10 equals 1 million times 10 equals 10 million times 10 equals 100 million. And then the highest it's ever gotten is a level 9. So that's your stopping place. And I mean, if it ever were to, like, the world was to go like crazy, maybe there'd be such thing as a level 10. But pretty much the Richter scale, it'll look like this whenever whenever you use it. They'll use these over here. But see, like, if you type this in on your calculator, and then like a formula would say like 100 over 10, and then you do that, you'll get, on your graph, you'll get something like this, and it'll just be like, and then some of the amplitudes, they'll go like this, they'll just be like scribbly, and then they'll go up really high, and then down, and then up, and really high again, like up and down, up and down. It's sort of like a heartbeat thing that tracks your heart, like a heart monitor, but it tracks the amplitude of an earthquake. So that is the formula and the scale that is used to determine all of them, and just don't forget they're each multiplied by 10 each time to get the next level. Okay, so to solve this problem, you're going to use this right here, and the I right here stands for intensity, and this stands for standard earthquake intensity. Okay, so after you do that, you're going to put it equals log of, sorry, I have this written down on my iPad, log of 4I SF minus log of S. And the log of SF is San Francisco, because it was 4 times as strong as the one in South America. And then the next thing you're going to do is do log of 4 plus log of I intensity of San Francisco minus log of S. Okay, and then that's going to equal log of 4 plus log of intensity of San Francisco minus log of S, which that equals log of 4 plus log of I of San Francisco over S. Then you'll get log of 4 plus 8.3. And where you're getting this is, this was the This was the San Francisco. This is what it was registered as, the 8.3. This right here. That's where the San Francisco is registered from. And 4, you get the 4 from, the one in South America was 4 times as strong. So that's where your 4 comes from and all here. And then SF is San Francisco. And all these, San Francisco. And then I'm going to erase all this and then go to my next part because I don't have enough room. And then once you get your log equals 4 plus 8.3, you'll type that in on your calculator. So log equals log of 4 plus 8.3, you'll get 0.6021. And then once you get that, you're going to add that to your 8.3. And then the magnitude of the earthquake in South America will equal 8.9. So honestly, the only tricky part about this is figuring out which numbers to put where. And the formula is actually very self-explanatory because it's saying like perfectly the measure of South America equals log of the intensity of San Francisco over S. So you'll just put your number down there. And it's actually really simple because all you do right here is just basic math. Like once you get to these two parts right here, it's basic math. But all you do is just type this in your calculator right here to get your answer. And if you just type this problem in exactly like this, you can skip all this right here and just get this answer right here. Okay, so for my second example, I used this problem, and where it starts off as is the intensity of earthquake 1 over the intensity of earthquake 2, which equals 25. And so you'll do intensity of 1 equals 25 times intensity of 2, and you're doing that because you want to multiply this to this so that you can get the intensity of the first one. Or you can get the magnitude of the first one. So we can write this equation as the magnitude of earthquake 1 times the minus the magnitude of 1 minus the magnitude of 2 as log of I1 over S equals the log of I2 over S. So it'll be the magnitude of the first one minus the magnitude of the second one, which will equal the logarithm of I of the first over S minus the logarithm of, just make sure you realize this minus, it's not a times, minus the logarithm of intensity 2 over S. And so that'll be the measure of 1 minus the measure of 2 equals logarithm of 25 times I over 2. So you multiply the second one by 25 like you did up here. And then you'll get minus the logarithm of intensity 2 over S. So then you'll have the measure of 1 minus the measure of 2, which will equal logarithm of 25 times I to the second I, or the second intensity over S. So you're putting all this over S, this part right here, so that you can get the standard earthquake measurement. And so then you'll subtract that from the logarithm of just the second intensity over S, which that'll equal the logarithm of 25 plus the logarithm of second intensity minus the logarithm of the standard minus logarithm of the second intensity plus the logarithm of S. And once you type this in like on your calculator, you can't type the variables in, so you just kind of have to like substitute those, like plus the logarithm of S and minus that, but you can just cross those out because they cancel each other out. So then you'll have these two, and you can cross those out because they're that. So you'll do the logarithm of 25, and once you do the logarithm of 25, you get 1.397, which that'll equal the magnitude of 1 minus the magnitude of 2, which equals, or is similar to 1.4. And if you didn't understand why I just crossed these out here, this right here is a plus sign, and this one right here is subtraction sign, and they're the exact same thing, so they cancel each other out since they're equals. Like if you were going to do like 4 equals 4, you would cross it out, or 4 equals negative 4. You would subtract 4 from the positive 4 and put it over here, and you add 4 and you get 0. It's just basic math, and that's pretty much all this is. Like the whole entire Richter scale thing is like very easy. You just have to understand what it's being used for and how to figure out intensities. So that is my video, and thank you for watching.